and thank you for coming here. I am Bea, and I'm going to be talking about how we reduce the size of our app at SwiftKey. SwiftKey is this first app there. We are part of Microsoft UK, and we are part of a group called MMX, which does all of those apps. Not all of those apps. What happened there? Sorry. Third time lucky? Yes, so these are the apps of the MMX team. Your phone, To-Do, Launcher, OneNote, and Edge. We're just one of the many teams working on Android in Microsoft. They do a lot of other apps. There are actually over 150 of them, and the most famous ones are all the Office suite, Word, Excel, all of those. But we're going to talk about SwiftKey today, and here's a video to show you what it is. That was a video to show you what it was. I'm sorry, we're having presentations issues here. It doesn't play. No. OK, without the video, I'm really sorry about this. It's a smart keyboard that lets you type in up to 5 languages at a time, and you can tap on the keys, or you can move your finger around, which we call flow, and other people call swipe, and you know what it is. You move your finger, you get like a line there. You get predictions, you get corrections. We support, last week I checked, it was like 664 languages. That's a variety of scripts and a variety of ways of typing. The people who do that, as I said, are based in London. There's about 80 of us working on everything you need to get the keyboard working, a lot of machine learning, a lot of cloud, lots of designer, analytics, PMs, and about 20 people working on the mobile apps, both Android and iOS. Actually, most of us are working on Android. And today we're going to be talking about the work that 4 of us did. My colleagues, Oli, Provin, Abdelhak, and myself, worked on making the APK smaller last year. And they can't be here today, so you're stuck with me for the next few minutes, talking about reducing the install size and download size and why that matters. First of all, what do I mean when I say app size? There are different metrics that we can look at. And the easiest one of them is the APK size. That is just what you get when you build your app. You get an APK file, it has a size, and there's not much more to it. It gives you a number in megabytes. Then the download side is what you get, is the data you need to download the app from Google Play. And this is reported in the listing of the app in Google Play. And it also just gives you the number, making some calculations about what your phone needs. And depends on how you upload it. And finally, the install size. That is the space it takes once it's installed into your device. That's the storage that it's using. And that's what you can see if you look in the settings. And they're all different numbers. They vary quite a lot. The biggest one is the install size. That's the one that most people look at. And they matter because of different reasons. First of all, the download size. We can see the map of the median download size of apps around the world, and we can see that it varies a lot per region. So it's a nice reminder that if you have a relatively new phone and you have connectivity all the time, you live in a privileged bubble, and that's not how your users experience your app. So in the regions in red, the median download size is about 5 megabytes, while in the regions in green is about 25 megabytes. It's quite a big difference. It depends on the connectivity in the region, and also in the affordability of data. For some people, it's really expensive compared to the salary to just download something from the internet. When we started looking at that, we realized that SwiftKey was even bigger than the median download size in the developed countries. That was something that we needed to fix. There is some research by Google that matches our own findings as well, and it shows that the smaller your app is, the higher the conversion rate is. That is, of the people who look at your app in the Google Play listing, more of them will, well, a higher percentage of them will click on the download button. And of those who click on the download button, they will get your app installed. And then, well, we have to be good citizens and only use the resources we need and leave the rest for the user. And that's very nice thinking, but we also need to do it because we are selfish. Because if Android is very good at telling people to get rid of things they're not using, you know, you see things saying like, remove these old photos, or this app is really big, it's taking up a lot of space. Especially Android Go also tells people, you haven't used this app in a while, perhaps you want to uninstall it. We want people to use our app, so we don't want people to see these notifications asking them to remove them. There's also another good reason that will apply to some apps. That is that both the APK size and the install size matter to manufacturers who pre-install apps on their phones. So when you unbox a phone, it comes with some apps, and they're already there, ready to be used, and they really don't like it if they take up a lot of space, because space is very valuable for them. So if you want to partner with manufacturers, your apps need to be very small. Having a closer look at the install size, the first thing that gets into your phone is the APK as it is. While the app is being built, all the Java and Kotlin code will be compiled into a DEX file that is compressed inside of the APK. At the installation time, this file that is compressed is extracted outside and verified, creating a VDEX file. So just after installation, you get an extra percentage there taking up space. And in our case, that was 25% more. Then, if you're using the Android default behavior, all the native libraries you're using are also compressed inside the APK, and at the installation time, they are extracted outside. And in our case, that was 11% more. That will vary per app. And this is just after installing it, unless you're using Google Cloud optimized profiles, which I'll get back to it in a minute. After a few days of using your app, what happens is that the most frequent paths are also optimized, and the system creates a different DEX file. This is an ODEX, optimized DEX file, which adds some of the percentage as well that comes to the install size. And what happens with the Google Cloud optimized profile that I just mentioned is that if enough users are using your app already, for example, if you have published a beta or you are doing a stage rollout, and Google has been able to calculate these paths on the cloud, then that will be downloaded at installation time as well, provided you are on a recent Android version, which I think is P, but I'm not really sure right now. This code lets you check which optimizing profile you're using, so you can play with different ones and try to see what would happen if I was optimized for this on this device or on this other, and you can just play with it and see different numbers. So we have seen that code is triple taxed because every Java and Kotlin code will be counted in the DEX, in the ODEX, and in the VDEX as well. Native libraries are double taxed because they will be counted, compressed inside the app, and extracted outside the app as well, inside the APK, sorry, and outside the APK. And we also need to have a look at the resources. So we're going to have a look at these three things and see what we have done about them. These are the things that we were doing wrong and we improved. These are not necessarily all the things that you can do for your own apps. It's just suggestions about what might help you if you want to have a look at these things. First of all, the code. Proguard is the tool that we use when we want to reduce some of the code. And in our case, we had a Proguard configuration based on the default configuration that we had tweaked over time, and different people had been adding little thing here, little thing there, but no one really had a good look at it, and we didn't really know what it was doing until we looked at it closely. Our configuration looks something like that, and this looks like we are disabling some optimizations and enabling some others. But we realized that optimizations is actually a filter, and only the things that match the filter will be applied. So from the ones at the top, when we are disabling something, everything that is not that will match the filter and will be applied. But with the ones in the bottom, only those will match the filter and will be applied. So the moment you use one of those in the bottom, you think you are enabling something. What you're actually doing is you are disabling everything else. And we had quite a few of those. So I suggest you don't do that. We just remove all of them, and it was fine. Another thing is that Proguard changes over time, and it's good to have a look at the documentation and see what's there that could help you. We found these two flags that helped us reduce the size a little bit. They both come with caveats, like you have to be using obfuscation and some particular things. Have a look at them, see if you can use them, or see if there are some others that you find there that are interesting. I just suggest read the documentation because there's a lot and it keeps changing. We saw some optimizations that were disabled by default, and actually the last one of them, you don't really need it. It's only for Android below 2.0, which I guess no one is using now, I hope. Is someone using it? You're laughing a lot. Yeah. So yeah, we did all of these things. And I also learned yesterday in a talk by Saul that there's optimized Proguard configuration. So that would be another thing to try. We didn't know about it, so we didn't try that. We did all of these things, and we managed to reduce the deck size by the deck's method number by 11%, the size by 9%, and that brought the overall install size down by 2%. Then R8 came, and I am not an R8 expert. We turned the flag on, and we saw a size reduction, but also a performance progression. We have these bots that are linked to every PR in GitHub, so every time you try to merge something, it tells you what the size difference is going to be and what the performance difference is going to be. So we initially said, okay, let's not use R8 because it's making the app slower. But a couple of Gradle releases later, we tried it again, and it was fine. So we think there was something with Gradle or the Gradle plugin, and it's actually fine. We're using it now, and we reduced that 1.3 megabytes with R8. Going back to the native libraries, I said the default behavior was the native libraries are compressed inside the APK, and then we extract them outside. But it's possible to reverse this behavior. So if we want, with a flag in build.gradle and a flag in the manifest, we can put them not compressed inside the APK and then use them directly from the APK. So you make the APK slightly bigger, but you skip all of the space out of the APK at installation time. Try to see if there's a performance problem or not. It was very well for us, it worked. So we're using that. Also remember that native libraries are not only yours, the third-party libraries may bring them with them. And also some of these third-party libraries may bring their own way of extracting native libraries with them. So maybe your configuration won't be applied to all of the native libraries you have. And we get to the resources, which also take up quite a lot of space. The first thing to do with the resources is that not have the ones you don't need. Proguard removes them for you, Gradle removes them for you. There's a link check that tells you which ones are unused, and there's a button in Android Studio to remove all of the unused ones. So there's really no excuse to have things you don't need in your app. But however, there are some resources that we do need, and we need to make them as small as possible. So we had a lot of images, and initially they were all PNGs. Then we heard about WebP, which is a more compressed format. It allows to have smaller images that are 25% smaller without any quality loss. And if you can allow some quality loss, they can get even smaller. You can think you can use SVGs for this, and yes, that's fine, that's correct. But SVGs are harder to produce, and then vector drawables take longer to load. So it's probably going to be a lot of work to convert all of them. Some of them won't be able to be converted, and this is just 2 clicks. Is right-click on the drawable folder, and then click on Convert to WebP, next, 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 and you'll have all the images converted. We saved a couple of megabytes with this as well. The translations are another big source of waste. So when strings are compiled, they go into a structure that is like a matrix, and there's a row per string ID and a column per language, where every cell has the translation of the string with the ID of the row in the language of the column. In the example here, we have one string translated into English and Spanish, and it's very intuitive to think that we have one copy of the string in English and one copy of the string in Spanish. What is not so intuitive is what happens when a library brings a new string. So if this string isn't translated into all of our languages, it will take our whole row in our matrix, only that for the languages that that string is not translated into, it will be a null value or a no value. So we'll have some space full of nothing. Then it's even worse if the library also brings new languages, because we not only get a new row, we also get a new column. And it will be mostly full of no value as well, just taking my space for no good reason. There's nothing we can do for the first case, but for the second case, we can remove the columns we don't need, so the languages we don't need in the translation. And we can do that by selecting which languages we do want in build.gradle. with that command over there. In our case, we have 72 languages, which can seem quite a lot, but still reducing the number of languages to 72 gave us another gain between 1 and 2 megabytes. And just to clarify, these are the languages the app is translated into, so the languages that every app has. This is not the languages that you can use in the keyboard to type, which, as I said, those were like 664. And all of these improvements for languages, they don't really matter that much now if you're using dynamic delivery. So it depends on what you're using. You may find that helpful or not. With dynamic delivery, it's a new app serving model. Before it existed, the app serving model was based on APKs. People just compile an APK, put the APK on Google Play in the most simple case, and everyone gets the same APK. So everyone gets a lot of stuff that they don't need because they get resources they don't need, languages they don't need, APIs they don't need. But it's very simple. After this, we got multi-APK, which was a bit better because it allowed us to split the APKs in different dimensions, like APIs or screen densities or languages. And that lets you have multiple ones. Each one of them is smaller. Then you can put them all onto Google Play, and everyone will get the APK that matches the configuration of their device better. We looked into this, and we decided that we would get the biggest gain with the smallest effort if we divided them per API. So all the native libraries will only be in one of the APKs, and then people will only get the APK with the native libraries that they need. They will still get all of the images and all of the translations, but that was okay. Because if you think of dividing this even more, you will get 3 APKs per API times 4 screen densities that we support times 72 languages, and that is not the number of APKs that anyone wants to manage. So we stopped there. And this problem is common enough that it was solved a while later with dynamic delivery, in which developers build an Android app bundle, AAB, instead of an APK, and that contains everything that anyone may need. We put that onto Google Play, and then Google Play is able to create different APKs based on that. So it will create one base APK, and then one configuration APK per API, per screen density, and per language. And then every device can get the base APK and any other configuration APK it may need, depending on the configuration of the device. And when the configuration of the device changes, for example, if the locale changes, the new configuration APK will be automatically downloaded. The small problem with this is that you have to give Google your sign-in key so that they can sign the APKs with the same key that you're using. We thought about that. Eventually decided that we are trusting Google by putting our apps in Google Play and by running our apps on their operating system. So we may as well trust them with our sign-in key as well. But other people's opinions vary. This is a GIF that summarizes the process of downloading an APK, an app, with the previous legacy system and with dynamic delivery. And you can see how with the APK one, you have to download everything. You get a lot of stuff that you're never going to use. And with the new one, you just get little bits and you just get what you're going to use. It's just simpler and nicer. The further step from here is to use dynamic features as well, which allow users to download a feature only when they're going to use it. And that looks very interesting, but we haven't used it yet. Partially because we haven't released anything new that would suit this system, and because moving the existing features to be dynamic features wasn't worth it because, well, we didn't think of that before, so we are sharing libraries between different features. It was very difficult to extract a single one of them, and it's quite a hassle to just remove a few views. If you're not going to remove something big, we thought it wasn't worth it. So we're not using that yet, but it's promising. And so far, these have been generic things that hopefully apply to some other apps as well. There were some things that apply mostly to the keyboard. So we were putting the English US language in our app. It was always there. It was in case we couldn't get the language that was suitable for you, we would just give you English US. but we realized that people didn't really speak English US. We had users all over the world, and having English by default wasn't helping. It was better to have no language. It was also a couple of megabytes that we could remove. So that was gone. And we also had a lot of keyboard layouts. You can think of all the different layouts for the different scripts that many languages can have, and then multiply that times phones and tablets and portrait and landscape, bigger and smaller and floating and split in the middle. It's just a lot of XML files that we had to define all the layouts. That was taking up a lot of space, and we turned that into some data format similar to Proguard. That let us remove a lot of space as well. So putting all of that together, this was what our install size was at the beginning of this process. You can see all the different patterns, all the code, graphics, layout, the English US, and translations. And when we did the first part of the work, you can see a small reduction in most of them, but especially in graphics and keyboard layouts. And then by moving to app bundles, we managed to reduce it even further, especially in graphics and translations again. In total, with all of these things, we managed to reduce the download size by 50% from 28 megabytes to 14, which we thought was quite good. And we also managed to decrease the install size by 40% from 81 to 48. And we were really happy with these numbers. But how do we know if this is what we wanted to do? Is this enough? Should we go any further? We also looked at the download size over time and the Google Play conversion rate over time as well. And as I said before, we had research that suggested that if we reduce the size, the conversion rate would go up. This was going to be especially noticeable in India, Indonesia, and Brazil. It turned out we only noticed it in Indonesia, but we can see the decrease is quite clear. And it also flattens over time. It's not a linear relationship, which is good. It means we've done enough. It also means if we remove everything, not everyone will download it. So it is just good to know. And this is pretty much what I wanted to share. I think it's been a bit fast. If you have any questions.
Any questions?
Hi.
Hello.
Hello. Thanks for the talk. It was really, really interesting. I wanted to know if there was if you had a lot of hassle moving from the normal distribution to the bundle tool. I mean, in terms of, did you have to was it like seamless besides moving the signing key to Google, or did you have to run tests to ensure everything was working? Was something failing at the beginning?
So the conclusion is that it was seamless, but we did a lot of testing before that. We really tested going from APK to bundle. We tested going from releasing a bundle to releasing an APK as well in case something went wrong and we had to revert. We have apps that are pre-installed, as I said at the beginning, so we also tested what happens if the app is pre-installed and then we go to app bundles, and what happens if you update an app bundle with another app bundle and changing the locale. We did as many tests as we could think of, and they were all fine, so we just decided to go for it, and it was absolutely seamless, no bugs, no problems, no regrets. Yeah, I suggest you do it.
Okay, thank you very much.
How many people are using app bundles, out of curiosity? Okay, that's like half.
Yeah, thanks for the talk. So follow-up question actually related to app bundles. We did the same and we went like all in, but we faced the issue that users were actually side-loading the applications. So as in, like, you don't download it from Google Pay, but you have the application and you install it in another phone. And we had crashes and users complaining because like they installed the app in a weird way, and then some resources like could not match. You know, like the drawables had different density on something. You didn't have anything like this, or?
Well, yeah, we did see that some people were side-loading it, but we decided we don't support them. They should get it from Google Play. It's free on Google Play. It may be because it's not available in some regions, but yes, we don't support it.
Okay, thanks.
There is a Google API to check for missing places.
Yeah, but I think
in
it.
your app, you can detect if it was sideloaded and it's using Switch, then you can tell the user that game is installed.
Okay, thanks for the talk. So you told that you converted your XML to some binary formats. Do you have some numbers? So how much space have you decreased by moving to this binary format?
I don't know the number off the top of my head. I have the diagram. This one here. So it's the big one at the bottom, and it goes about half. I don't know the exact number, sorry. But it was quite a lot. And the format is based on protobuf.
Okay, thank you.
Welcome.
Yeah, hello. Thanks for the talk first. And speaking about changing locale, you said you made some testing and there was no problem.
Yeah.
If you have an app with a lot of locale and user is changing the language of the app, how this is impacting the user experience? Like he's downloading the language once he changes? Or
Yes, so you can't change at least not on our app, you can't change the language of the app. Is when you change the locale of the phone or of the tablet, the locale of the system, then Google Play automatically gets it and downloads it. So if the user is downloading a lot of locales or enabling a lot of locales, they may want to use them. It all happens automatically. But yeah, there are people who speak many languages and they have a lot of locales enabled, and they will just have as many packs of translations as locales they have enabled. It's up to the user. And it's quite nice to see which apps are using app bundles. If you change the locale on your phone, you will see how Google Play starts downloading things. Those are the apps using app bundles.
More questions? No? Thank you very much, Beatriz, for your talk.